Imagine the universe as a noisy concert that has just wrapped up its explosive opening act. The Big Bang was the fireworks show, the first second was pure chaos, and now the stage is set for the next part of the performance. The birth of atoms. It may sound quiet and technical, but in reality, it was one of the most dramatic and important episodes in cosmic history. Without this stage, there would be no stars, no planets, and certainly no you. Roughly 3 minutes after the Big Bang, the universe is still absurdly hot, hundreds of millions of degrees, but just cool enough for something new to happen. Protons and neutrons, the tiny stickman particles we met earlier, start bumping into each other and forming partnerships. This marks the beginning of Big Bang nucleosynthesis. It sounds like a fancy lab experiment, but really it was more like a frantic speed dating session. Protons and neutrons rushed around in a desperate attempt to pair up before the universe expanded too much and ruined the vibe. The result? The first atomic nuclei, but don't expect a full periodic table yet. At this stage, the universe was only capable of producing hydrogen, helium, and the tiniest sprinkling of lithium. Imagine a stickman professor proudly writing hydrogen, helium, lithium on a chalkboard, then dramatically dropping the chalk. That's it, folks. See you again in a few billion years when stars take over. The rest of the elements, like carbon, oxygen, and iron, would have to wait until the first stars were born and exploded in supernovas. Forming even these simple elements wasn't easy. The universe was expanding like a balloon on steroids, pulling everything apart at insane speeds. Picture protons and neutrons as stickmen, clinging to each other while a giant referee, the expanding cosmos, tries to drag them apart. For just a few golden minutes, conditions were perfect. Hot enough for collisions, but not too hot to rip everything apart. In this tiny window of opportunity, helium nuclei managed to form. When the moment passed, the cosmic factory shut down, leaving behind a universe stocked with about 75% hydrogen and 25% helium, plus a trace of lithium. That was the menu for billions of years to come. Now comes the long wait. For hundreds of thousands of years, the universe remained a swirling, glowing fog. Electrons, the tiny stickman troublemakers, zipped around chaotically, constantly getting knocked away by high-energy photons. Imagine electrons trying to settle down into families, but hyperactive photons keep barging in like rude party crashers. The result was a cosmic traffic jam, where light couldn't travel freely, bouncing from particle to particle like a pinball machine. Finally, after about 380,000 years, the universe cooled enough for something revolutionary. Electrons could finally attach themselves to nuclei. This event is misleadingly called recombination, but in truth it was the first real combination. Picture a cosmic wedding ceremony. Stickman protons and neutrons stand proudly as the nucleus, while an electron arrives, slipping a ring on its partner's hand. Photons, kicked out of the celebration, storm away and finally fly free into the universe. For the first time in cosmic history, the fog cleared and the universe became transparent. Those liberated photons are still zooming around today, visible as the cosmic microwave background, the ultimate baby photo of the universe. At this stage, atoms of hydrogen and helium drifted quietly through space. On their own, they may not sound impressive, but these were the raw ingredients for everything else. Gravity would eventually gather them together into massive clouds, which collapsed to form the first stars. Those stars would fuse hydrogen and helium into heavier elements, seeding the universe with the material for planets, oceans, and life. But all of that depended on this critical moment, the birth of atoms. So the universe that once looked like a blinding fireball had now transformed into a calmer, darker sea filled with the first real matter. From the frantic 3-minute element factory to the long, foggy wait, to the final wedding of electrons and nuclei, the story of atoms was complete. Without it, nothing else could follow. The next time you look at the night sky, remember, every atom in your body, every bit of carbon, oxygen, calcium, and iron traces its ancestry back to this era. It all began with hydrogen broth and helium sprinkles drifting silently through space. The universe gave birth to atoms, and in doing so, unlocked the possibility of everything that would come after. Stars, galaxies, planets, and civilizations made of stardust.